Okay, these last two pages are all about graphs. So it says list the domain and range. So in order to list the domain and range, you want to put in your asymptotes. So we have an asymptote here, which is y equals 1. And then we have an asymptote here, which is x equals 2. Once you have your asymptotes, then you can list your domain and range. Remember, the domain and range is going to be all real numbers except the excluded values. So a domain is negative infinity to 2, union 2 to positive infinity. And for this one, we have range negative infinity to 1, union 1 to infinity. Let's look at the next one. Next one's a little trickier because notice we have a function going right through our horizontal asymptote. So we do have a horizontal asymptote here, but it doesn't have any bearing on our range, which is y equals negative 1. But we do have two vertical asymptotes. So vertical asymptote here, at x equals negative 1. And then we have another vertical asymptote here at x equals 2. So our domain is going to be negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. And then our range, now even though we do have a horizontal asymptote, the range goes through that horizontal asymptote, because remember our horizontal asymptote only explains to us our end behavior, so negative infinity to infinity. And the last one, so for the last one, they don't give you a graph, but you still should be able to figure out what your domain and range are. What you'll need to do is you need to factor both of them. So at the top, if I factor it, I have x plus 7, and then x minus 4. And the bottom, I have x plus 4. I'm sorry, x plus 7, x plus 1. Remember, if I have something I can cancel out, that's going to be a whole. So I have a whole at negative 7. And to figure out what your other whole is, you're going to substitute it into what remains. So if I substitute my negative 7 in there, I'm just going to plug that right into the calculator. So my numerator, I'd have negative 7, alpha y equals negative 7 minus 4. And then I have negative 7 plus 1, enter, which gives me 11 over 6. So I have a whole here. This is my whole. And then I have a vertical asymptote. It does other values, so x plus 1 equals 0. So I'm going to minus 1, so x equals negative 1. So I have a vertical asymptote at negative 1. And then if we look here, our degree is the same, which means I have a horizontal asymptote at y equals 1. Alright, so my domain is going to be negative infinity 2. So I've got the whole at negative 7, and then a vertical asymptote at negative 1. Negative 7, union negative 7, to negative 1, union negative 1 to infinity. And then my range is going to be negative infinity to 1, union 1 with 11 over 6. Because don't forget I have this hole here, and I have my horizontal asymptote. Union 11 over 6 to infinity. Alright, moving on down. Okay, this says list your excluded values, holes, vertical asymptotes, horizontal asymptotes, domain, and range. Alright, so in order to do these, you must factor. So if I factor the top, I'm not going to spend the time in the video to factor the top. You need to know how to do this. So if I factor the top, I get 4x minus 1, x minus 1, x plus 1, x minus 1. All right. So you want to look to see if there are any holes. Can I cross anything out? Yep, I can cross this out, which means that my hole is going to be at 1, comma. And I got the 1 because I said x minus 1 equals 0 plus 1 plus 1. So I have a hole at x equals 1, which is my x value. Now to find my y value, I'm going to substitute this back into what's left. So 4 times 1 minus 1 over 1 plus 1. So I have a hole at 3 over 2. And we know that our hole x equals 1 is an excluded value, and then we have our other excluded value, which is here, which is a vertical asymptote. So I have an excluded value of -1, but that's where my vertical asymptote is, and x equals -1. So remember, cancel out your hole first, and then you have your vertical asymptote. Horizontal asymptote, we're going to go back up here. We're going to look to see the degree is the same. So I'm going to look at the leading coefficients. I have 4 over 1. So y equals 4 is my horizontal asymptote. Now we can do the domain. The domain is going to correspond to my excluded values. So negative infinity, -1, union, -1 to 1, union 1 to infinity. And then typically my horizontal asymptote corresponds to my range, but also the y value of my hole corresponds to the range, because those are y values. All right, so I have negative infinity to 3 over 2, union 3 over 2, 4, union 4 to infinity. Okay, next one, we're going to factor. If we factor the top, we're going to get 2x minus 1, x plus 5. Again, if you don't know how to factor, you need to come see me, because you've got to be able to factor on the test, because the ones on the test are not factored. The bottom is going to be 2x plus 1, 2x minus 1, x plus 3. Check to see if there's any holes. So I have a hole here. So that's going to give me a hole at 1/2. And we're going to substitute back in 1/2 to whatever's left to get my y value of my hole. Remember, a hole is also going to be an excluded value. So alpha y equals, so I have 0.5 plus 5 over 2 times 0.5 plus 1 times 0.5 plus 3. I forgot my other parentheses. Changing that to a fraction, I've got 11 over 14. Alright, and then we've got our vertical asymptote. So what's left here are going to be vertical asymptotes, because we didn't cross anything out. So we have x equals -1/2, and then x equals -3. Just set each of those equal to 0. Horizontal asymptote, look at the degree. The degree is more in the denominator, so I know my horizontal asymptote is x equals 0. Alright, last one, we're going to factor. We've got x minus 4, x plus 2, over x minus 3, x plus 2. Alright, there's my hole. So I have a hole at 2, comma. And then to get that y value, I'm going to plug that in. alpha y equals 2 minus 4 over 2 minus 3. So my y value is going to be at my y value is x negative 2, right? X plus 2 equals 0, minus 2, x equals negative 2. So let's plug that into the calculator. So I have negative 2 minus 4 over negative 2 minus 3. So that's going to give me 8 over 5. But that's not correct because I didn't put it in right. Negative 2 minus 4 over negative 2 minus 3. There we go, 6 over 5. Okay, so we know one of our excluded values is at negative 2, and then the other excluded value is going to be this x minus 3 equals 0, so x equals 3. And that's going to be a vertical asymptote. Horizontal asymptote, we're going to look at the degree. The degree is the same, so we're going to look at the leading coefficients. Leading coefficient is 1 over 1, so y equals 1. So now you can list your domain and range. Domain is negative infinity to negative 2. Looking at the excluded values for my domain. Union negative 2, 3, union 3 to infinity. Range is going to correspond to my horizontal asymptote and the y value of my hole. So negative infinity to 1, union 1, 6 over 5, union 6 over 5, positive infinity. Okay? Alright, last thing is one of these, or actually we're going to do 2 of them. Alright, so in order to do these, you've got to factor them. So the top factors to 2x minus 3, x minus 4 over x times x minus 4. Okay, so I have a whole. So my whole, the x value of my whole is going to be at 4. To figure out my y value, I'm going to substitute back in. It's just going to give me 5 over 4. Here's my whole. And we know that the excluded value is x equals 4. And then this number right here, to make this 0, you go x equals 0. You don't have to solve anything, so my other excluded value is 0. So we know 4 is the whole, which means the other one has to be my vertical asymptote. Alright, and then our horizontal asymptote, degree is the same, leading coefficients, y equals 2. And you can look here. Now the holes you won't be able to see, but x equals 0. Okay. So there's my vertical asymptote, and I have y equals 2. It's my horizontal asymptote, so you can see how that fits in. And again, you won't be able to see that hole there. It won't show on the graph. All right, let's go and fill in the rest. Function family is rational function. Parent equation of f of x equals 1 over x. We filled all that out. Domain. So domain is this excluded value. So domain is negative infinity to 0, union 0 to 4, union 4 to infinity. Range. Okay, so range is my horizontal asymptote and the y value of my whole. So negative infinity, 5 over 4, union 5 over 4, 2, union 2 to infinity. Increasing or decreasing intervals, so if I'm going, that's going up, up, so they both are increasing, which means if it's an increasing interval, it's going to match my domain. So I can just relist my domain here. negative infinity to 0, union 0 to 4, union 4 to infinity. No decreasing. And remember that your end behavior is going to match your horizontal asymptote. So as x approaches infinity, f of x approaches 2. As x approaches negative infinity, f of x approaches 2. All right, last one. Factor. X plus 1, x minus 1, and on the bottom, x minus 2, x plus 1. Function family, we just said it, rational function. Parent equation, f of x equals 1 over x. Excluded values, anything that makes the denominator 0. So I've got an excluded value at 2 and negative 1. Okay. We've got to look to see if we need to cross anything out, which I can. I've got that x plus 1. X plus 1, that means that's where the hole is. So the hole is at negative 1, and to find the y value, substitute negative 1 back in here, which is going to give me 2 over 3. Here's my hole. Vertical asymptote is going to be this value here, which is x equals 2. Horizontal asymptote, degree is the same. Look at the leading coefficients, which is 1 over 1, so y equals 1. All right, domain. Domain is your excluded values. All real numbers except your excluded values. Negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. Range is going to be my horizontal and the y value of my hole. Negative infinity to 2 over 3, union 2 over 3 to 1, union 1 to infinity. Increasing, decreasing intervals. Again, you can check those vertical and horizontal asymptotes. The hole you won't be able to see. Vertical asymptote, x equals 2. Horizontal asymptote, y equals 1. Increasing, decreasing, so this is going down, down, so there's no increasing. Decreasing is going to match your domain. Negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. And then as x approaches infinity, f of x approaches this horizontal asymptote. That's it. Good luck on this test.